Now we're going to talk about compound inequalities. The first type is or, and then on the next lesson it would be the and type. But right now it's or. So two or more inequalities graphed together on the same line. You can always pause the video to write down things that I've written ahead of time. So if we look at this inequality right here, you'll see we've got the closed circle on -4, and then it's going to the negative side to infinity. So since it's a closed circle, then we say it's less than or equal to -4. Then on the other side is an open circle on 1. So that's going to be or x is greater than 1 because they're both on the same number line. So interval notation, remember when we have infinity going to the left, it's going to be parentheses there. So an open parenthesis with negative infinity. And then it ends with -4. And when that's a less than or equal to, then we end up with a bracket here to say that it's a closed set. Now the new information today is this, which means union. So we would read that as union, which means both things are on the same line. So it's a union of sets. So the 1 is an open set because it doesn't include 1. And then we have infinity going to the right. That is interval notation. Then set notation is these fun little brace things. And then we write our x like that. And then we do basically what we had up above in the inequality. X is less than or equal to -4, sorry. And then we put or x is greater than 1. And then we have the end brace. All right, so let's do some examples here. On number 1, I've got two different problems. See this or in the middle? So I've got these two things set up that I need to solve. So I'm going to solve them just like there's an equal sign there in the middle. There isn't, but where the less than sign is or the greater than sign, we're going to pretend like that's an equals and solve the inequality that way. So we start subtracting 4 from both sides. Then we're going to have 3x less than or equal to 6. Then I need to divide both sides by 3. And then x is less than or equal to 2. So I've got 2 here. I'm going to graph. So it's or equal to. So I'm going to put close dot. My dog's making all kinds of noise down there. Close dot and then going to the left to infinity. So I'm going to put for the interval notation negative infinity because it goes forever and ever and ever on the negative side. And then we have 2 with the closed bracket for the closed set. And then I'm going to put the union sign. And then up here I need to go back and solve this equation. So let me put this in a different color. So now I've got 5x is greater than 45. So I just solve it like normal. X was multiplied by 5, so now I have to divide by 5 to undo that. So x is greater than 9. It does not include 9, so it's going to be an open circle. And then infinity to the right. So this would be an open set for 9. and then infinity. And infinity is always an open set as well. On the next one, we still have an or in there, so I've got these two different problems that I need to do. And then I'm going to graph them on that same line. So I have negative 3y plus 8 less than or equal to negative 7. So I do the addition and subtraction first. It's reverse PEMDAS, reverse order. So I've got negative 3y less than or equal to negative 15. Now, here is something you need to remember when we are dividing, because that's our next move here. We're going to divide through by negative 3 to get y by itself. That cancels. So when I divide by a negative, the sign changes direction. So instead of less than, now it is greater than or equal to, and negative 15 divided by negative 3 gives you 5. So I'm going to put here close dot because it's or equal to. And then we need to do the other side. I've got 10y minus 3, so I just need to add 3. And this is going to be negative 30. Then when I divide by 10, I get y less than or equal to negative 3. So here's my negative 3 off to the left. So when I write these, they're gonna kind of switch places because of the way that the thing, they were both less than to begin with, and now one is less than, which is going to be this side. The other was the greater than. So then when I write these with interval notation, I'm going to say the one on the left here is negative infinity. And then it's negative 3, and because that is a closed dot, it is a closed set there. So we have the bracket at the end instead of the parenthesis. So then I've got the union sign and bracket because it is or equal to 5, and then positive infinity with our end parenthesis there. And then let's look at number 5. There's a couple different ways you can do this. Normally when we look at 3 times something in parentheses, we would distribute. You don't always have to do that when you are solving for something. We're not simplifying right now, we're actually solving it. So if we look here, I can actually, oh, that was good. 3 is multiplied times this whole thing. So I can divide both sides by 3. And then I have negative 4. So that way I didn't have to multiply through and then divide and whatever. I just went ahead and took care of it just by dividing by 3. You can do the distributing if you would rather. Then this looks a little different because I have my 2k over here. I have to get the 5 to the other side and get 2k by itself. So remember 5 is positive. So I need to subtract from both sides. Then I'm going to divide by negative 2. And if you'll recall, when we divide the inequality by a negative, the sign flips. So I have k greater than -9/2. So 9/2, if we do 9 divided by 2, that gives us 4 with 1/2 left over, so 4.5. So if this is 4, this is 5, this is 6. So 4.5 is right here in the middle, except I didn't want to do that as a closed dot. I want to do it as an open one because it's not equal to. So this side of the interval notation is going to be closed set, starting with 4.5, and then it goes to positive infinity. And there's our, I'll put our union sign in a different color. Union. Then let's solve this other side. We've talked a bit about these when we have a fraction at the beginning. Again, you can distribute if you want. I prefer multiplying by the reciprocal. So 3/1 is the same as 3, right? And remember, when you multiply by the reciprocal, these 3's cancel, 1's cancel. And so you're just left with 15k minus 9. Then I just need to add 9. So don't get confused by this. You still have to write the 0, even though they cancel, yes, but you still have to bring the 0 down and say less than or equal to 0. So it's 15k. Then when you divide by 15, you still have k less than or equal to 0. So that's going to be this side. So we've got negative infinity here and 0. And that ends up with a bracket because it is or equal to. You know what? I just realized I goofed on that other side because it sort of looks like it's closed. Remember, this was an open circle. I'll put it above so it's a little bit more obvious. And since it's open, that means we have the parentheses there instead of that bracket. Closed, like right there, is your bracket.